Now, today we still didn't one thing I need everyone knows that in my class we will have a lot of calculations. But in the beginning we didn't directly to calculate it. We can use a lot of time because this year you will use 1 year to study the design. And the topic just design this one. Just design this one, so it's not very difficult. But you should know each details because before you study the three material mechanics, the structural mechanics, we will combine this together and use how to design this structure. Okay, so but before that, we should know some construction parts of the construction process of the buildings, steel structure buildings. For example, now I showed you the Shanghai Tall buildings. Can you tell me if you are engineers, how can you design this one for the construction? Shanghai Tall is very tall, height, almost 600 meters. So for you, how to deal with this problem? The first step is what?
Foundation.
Yes, foundation finished and then core, the middle core, right? And then the support column beams to fix them together. Okay, and so during construction step, you need to control what? Control which steps to keep safety. For example, you design the code. This is center, and you also design the column around this, right? And you will connection this one, right?
Yeah.
So this one we can make from the for this one column, we can make from the factory, right? And for this beam, for example, this is the beam. We can make from the factory. When we together, this is joint. So the joint will bearing a lot of force in here, right? It's very. If the joint is broken, it will broken all the thing. So you imagine the structural mechanics. This one is joint, right? This one, firstly, I simplify this one. Can anyone point the moment figures? Anyone who want to try this? Point the moment figures for this. Just a moment. Come here. Salom, Tananda. You two guys. Eliezer, you want to try? Who wants to plus?
It's coming.
This one, the first, second. Who want to point this one? Who want to try?
Oh, wait this moment.
Yes. Okay, I
It's coming.
I know, I'll just show you from here.
It's coming.
It's coming.
Where did you put that?
Go to I mean,
Yeah, you just go to
You want out?
Eh?
You can choose one. Which one you want?
no. Each joint is a moment.
Wait, moment. We find moment where there's fixed joint.
Just indicate where there's a moment.
Yeah. Draw the moment figure. Moment diagram.
No, just
Yes, the moment diagram.
Exactly. It's already saying.
Just a moment. Not showing first. Not actually. Just a moment diagram.
I've already forgotten.
Okay, I brought a much simple. For this one, you can plot moment figure. Moment.
Moment.
Wait, come and sit down. Yeah.
Come. Wait, it's the moment diagram.
Yeah, he's drawing, man.
Oh, yeah, drawing the moment diagram.
Yeah.
Oh, okay.
So you can come here.
Straight line.
It's not straight.
Remember, we have make videos.
It's not straight. It's not straight. It goes back.
Who can help Elisa? Salom, come here.
Come on. Yes, can be stuck like this.
2 months.
Okay, I simplified. Okay. This is much simpler.
Morris. Oh.
So I think you want homework. You want homework?
You need to know. I don't know why people don't answer. Yeah, you.
Yeah.
The moment, please. Just 2 months ago, you already finished almost.
A lot.
You forgot everything.
This holiday was too good.
But
Here.
Just go.
Nisa, just
Yeah,
I just know what I'm talking about.
Like this.
Nisa, just go.
Nisa, come.
Nisa, just go.
What are you doing?
Drawing the moment diagram.
Imperative.
I will help you. Who can analysis? Moment. Please I need you give me a right answer. This is the moment. Okay. And this one is the moment. Right? Can you remember?
Yes.
It is right.
Yes.
I only use 5 minutes to teach you. This is not my job. The force here apply here. There is a force apply here, and here separate this force. And then how to plot the moment? We cutting half, right? And this one will produce the moment in here.
Yeah.
Right? This is much complicated. We need to use the memory. Remember this case. Okay. And then for steel structure, for steel structure, it's much more complicated. It's like this structure. If we applied a force here, okay. Other thing. This joint is what? This joint is rigid.
Yeah.
Right? This joint is what? Brace, right? How to pronounce this?
Flex.
This joint is what?
The road. Oh, pin.
Not this. This is rigid point.
Yeah, that's fixed.
Fix it. And then if we use this plot, a point, that means
that's a hinge.
that the right is hinge. It's rigid. So the moment is different. different because parachute they will bearing their moment, right? And then the moment of field will be like this. Okay, and for this case means there is no moment, should be like this. I plot it as I want. Okay, this I just this may be wrong, but I want to show you is in this point the difference, right? So this point in structural mechanics means the joint. Okay, you will see a lot of joints to design. Like here. You can see these joint connections. That was this structure, this Euro code. I will give you the books. If you want to study, you can see it carefully. Okay. For example, this joint. You know how to connect the joint. I will teach you in the future, but now you can have image it how to connect these two joints. Welding and the bolts. Okay, so we come back. I know you understand. So the construction of the Shanghai Tower, I prepare a video for you. You can see it. So I close the voice. This is Jingmao Tower.
国经济社会发展成
是上海 Center，
是上海中心大厦。
Almost the highest buildings in the China.
上海中心大厦位于陆家嘴金融贸易区，集高档办公、酒店、零售、娱乐功能。
The three building all
城总建
this
筑面
is
积
有
57万平方米，由主楼和群房组成。主楼地下5层，地上120层，总高度达632米。
Okay.
Increase the volume.
Yeah, you can understand. You can understand. Well, I just show the construction.
核心筒体型变化大，竖向结构多，模板系统体型
You can see this column.
实
This
施
is
效率要求
such
高。
like beam
混凝土强度等级
connection
达
has
C
the
7
construction
核心筒结
layer
构
layer.
574米，高强混凝土超高层泵送是个难题。2. 钢结构施工将
You can see a lot of steel used to
钢结构总
construction.
用钢量达10万
That
吨，
means
构建
a lot of money.
空间分布广，吊装设备选型要求高。钢构件板材厚，高空焊接量大，施工环境
Almost
差，
use the widening
质
method.
量控制难。3.
To make
维持
the
运输
each
组织任
joint
务重，
together.
施工人员和建筑材料运输任务繁重，高效的垂直运输体系对施工效率有重要影响。4. 施工组织难度大，为提高投资效益，群房及主楼22层以下部位需要提前营业，施工组织面临许多新课题。针对本工程施工难度大、建设标准高、组织协调困难、社会影响显著等特点，我们将按照
Okay.
群房区主楼工程分为钢筋混凝土核心筒和外框架
You
两
can see in
条
the
线
center
实现
is
前后
concrete
合理搭接，
that put
影响
together
作业。
to
其
build.
他区域施工穿插进行，具体流程如下：一、吊装核心
The
筒
foundation
进
finish
行
the
性
make
钢
the
结构，
post
采用传统落地脚 脚手施工1至5层合金筒混
You
凝土。
can see now is the central
塔式液
operator.
压顶升构架平台脚手模板体系安装完成后，拆除落地脚手架。3. 合金筒6层剪力钢板吊装完成，安装南北侧2台 M1280D 塔吊，原有2台 M1280D 塔吊第一次爬升。4. 合金筒墙体施工至基层，开始安装钢结构外框架。
And make the
5.
make
合
it
金
around
筒
the
墙体施
make a
工
lot
至
of beams.
36层，巨型柱
You
安
can
装
see
至
when you finish
2
those
区外幕墙钢
some
结构
steps
系统开始安装。6. 核心筒墙
and then
体施工至
building
45
the
层，
the
基
column
面安装
the
机
column
场施工。
and then the next part
核心筒墙体施工至50层，开始群防钢
also
结
next
构施
part
工。8. 核心筒墙体
and
施
then
工至
finish
75层，群防结构
almost
封顶，
600
拆除该区塔
meters.
吊，开始幕墙安装。9. 核心筒墙体施工到顶，拆除钢平台模板脚手体系。10. 巨型柱安装至117层，8区横架层施工完成，拆除东西侧2台 M1280D 塔吊。11. 屋顶皇冠结构施工完毕。12. 屋顶皇冠幕墙完
Okay,
成。
this is right now.
工程施工现场总平面布置将遵循以人为本动。装模板后浇倒混凝土，为确保施工安全，构架平台联系钢梁拆除、复位与深壁横架水平钢构件安装应交替进行。本工程混凝土浇筑最大高度达600多米，我们将采用一泵到顶的方案进行施工。
So come back. Right now you know the construction one.
So just wanted to ask, which one do you think is really buildings like those, like this very high buildings, when it comes to joining, you say one of the method of training that's welding, right?
For the yes working.
Welding, yeah. So I just wanted to ask which one is more advisable, like if you are when it comes to columns, do you think having many joints is a way or making it with like making joints?
Yes, make it up together. We will build winding and the bolt together. Very big bolt.
So that are there like an estimated number of joints on one group?
Sorry, I can get you.
Well, I'm saying since like these buildings are so high, right? Maybe around 100 meters or 1,000. So having like a lot of joints, like
Yes,
is it
yes.
safe?
You can see here. Some low lows. This is much. The radius is much bigger, and then here radius is smaller. It's like they have a slope, a little slope, make it safety. And here each connection we welding and the bolt together, make it ratchet connection, and then each part we will calculate. For you, you should calculate according to the code and make it safety. Know that? So it's very complicated to design, to build this one. It's it costs a lot, but never mind. Chinese government have a lot of money. Okay. Right? Do you have other questions? When you when finish your study, when finish 4 years, you want to work in China. Okay, you have questions? Okay, so we continue. So I also this is behavior of the height, but the some building is very big, large, a lot of function, like this CCTV center. So how to construction this one? Any? Do you have any idea? Sorry. About construction of about this building.
Yes.
So I also found for the videos for the these buildings, CCTV buildings. So
I will present CCTV,
it's much better. It's speaking
and
English.
I will also kind of present a little bit of the kind of history of CCTV. We actually chose for the Chinese project, and the reason was we knew very well what we were doing. China is a country that is modernizing. That means it is on the one hand enormous appetite for newness. On the other hand, it is uncertain, of course, where the modernization will end. But we felt it was very profound way are contextual, and this one is not an exception. We knew that the context was at that point virtual, but it would be a new CBD for Beijing, and the certainty was there that eventually it would contain 300 skyscrapers, and that really made us think. It was obvious that in such a landscape and for such a program, it didn't make sense to
There's architecture part.
holiday homes. You see that the project is basically two buildings. This building fits almost in this void, but you also see that there's a kind of green ground. And that is for me one of the most crucial parts of CCTV, namely that the entire ground is green, and that it is not a building that consumes space in the city, but it is actually a building that generates space in the city. Not only is this kind of plinth in its entirety a kind of garden, but also the spaces in between, and next to it is a kind of big park. So CCTV is a kind of rare skyscraper that actually returns to the city an enormous amount of genuine and new public space. You can recognize probably a pattern. This is a translation of Piranesi's plan for Rome, or of Rome, but translated in green and in vegetation. CCTV is a kind of building almost without any repetition, therefore very complex. There's a plinth, I will kind of show it later. Then there are two towers, each dedicated to different activities. This one is broadcasting, this one is offices and script writing and filmmaking, and then there's an L for the management of the entire company. But it's really a building, as I said, without repetition, but also a building that has a number of very specific organs. The ground floor is in its entirety a studio complex of more than 12 studios, where many of Chinese CCTV's films and movies and TV programs are fabricated in-house. Here you see the specificity of the kind of broadcasting. Here you see the kind of management floor. And what is perhaps the most important contribution that we kind of made already in the competition phase, and which is executed and which will kind of soon open. There is a single loop that goes in the basement and confronts and allows Chinese public to look at the process of TV making, then to go up, then have a kind of public level here where they are enjoying a view, and where they go down in a single movement. So a key element of CCTV is simply this kind of public loop that enables the Chinese public for the first time to enter the inner workings of TV making. As I said, CCTV is in a profound way an encounter between different cultures. Here you see the different people that were involved, but here you see the different nationalities. More than 30 different nationalities, but from the beginning, more than half of the architects were Chinese. We worked together with Ekadi, the Shanghai Chinese proposed is that we would meet kind of regularly and informally with a group of 150 of the most senior Chinese engineers, the most senior Chinese thinkers about structure, and would try to convince them of kind of the logic and the plausibility of our structure. The skepticism was extremely high, and the rigor was also extremely high. Basically, a Marxist engineer wants loads to go, and anything the sheer computer power of a building like this could never have happened. The engineering actually is an important part of the architecture. What you see here is the diagrid in its pure form. Here the stresses that the shape imposes on the diagrid. And then the most important decision I think taken in the course of the project in general is that we would not necessarily reinforce the points of stress, but simply double the points of stress, so that what looks to some extent as a kind of arbitrary drawing on the building is in fact a very precise diagram of the stresses and a very efficient way of dealing with the stresses over the entire surface of the building. As I said, the amount of knowledge generated for this building is kind of generally exceptional. In the end of more than 3,000 elements we knew, and we had kind of graphic representation of their behavior under almost any condition. We knew exactly what would fail, whether it was redundant, and what in the end that the building would be strong enough to withstand a kind of 1,000-year earthquake. A beautiful model kind of made for a shaking table test, where the structure was represented, where the steel was represented in copper. And then kind of finally the knowledge of the building was so extreme that in the end we had figured out, or Arab had figured out, that the famous coupling of the building, the famous connection, could only take place at 6 o'clock in the morning, when both kind of half of the building were sufficiently cold and cooled off, and so that the heat would not impose different extension factors. And so here the kind of sequence of connection between the different halves. I think it was the first time that time played part and a role in engineering. It's a building which I did with my company, and we see then quickly the kind of process from mud to an enormous. Here we are at the date of the groundbreaking ceremony, and we see then quickly the kind of process from mud to an enormous amount of concrete that was founded for the foundation, the complexity but also beauty of the different structural elements. They're putting together a single leg of the tower, the connection itself, the moment of connection, hair-raising kind of moments of balance, the sheer amount of structure at the top, and the Chinese worker. This is a building that perhaps the Chinese could never have invented, but it's for Chinese media to modernize itself. That will be inevitable to modernize themselves, because they need to compete, and they are competing not only in China with many different TV stations, but also internationally. And I think that competition alone will in itself have a profound effect on media in China, and is already having that profound effect. The building is a tool. It is connected to the underground It has incredible amount
The
of
inside of the
facilities,
building.
hospitals, sports facilities. Here you see the kind of dining, the workers entering the lobby, a view of the lobby between the elevator cores, one of the big studios. And you see that kind of one of the important things of all the interiors is that the presence of structure which characterizes the exterior is also very pronounced inside. It is really as if there's not a separate sculpture, but as if you're at every moment sharing space with sculpture inside the building. The control tower moment, here the so-called overhang, the point where the two elements join, which is, as I already announced, a public viewing point over the city with holes in which you see the park. And here, this kind of presence of structure inside the offices and characterizing in a kind of very different way every space. So it is really a tool that can now be kind of used, a tool with at least 200 different interiors, all unique and precise in themselves. It's also a building that is beginning to be loved by the users. This is a competition for representation of the building. I love you, CCTV. An important moment for me simply to see it. And then, of course, there's the presence of the building in the city. It's an icon, maybe, yes, but of course, Beijing.
央视新大楼尚在设计阶段，就引发。
So almost finished. Almost this part will finish. And for the national stadium, this one you also have idea, have logic to how to build in this one, right? A big farm running this and make the beam transport it together. If you have condition, you can also build for your home like this. Okay. So for the introduction part, I think it's all this one. So introduction part, in last class we also talked about this part, the types of the steel structural components. So how many types? Do you know the shell element? Shell element. You know or don't know? You know that? I will show you some clips in here. Shell element means this one. You can see the National Ground Theaters. For here, for this plant, small plant is the shells. The shell made from the steel, made by the steels. And also for this part, this is basic. This will this is the shell element. Normally use the liquid tank and pipe and other pipelines, and also the roof structures to use the shell element. Can you know that? And the cables. How many parts how many buildings you can see the cables? Which buildings? Yes, bridge, steel. And the tension compression bars. That means normally is the collar bars is rigid structures and truss structures. It can bear the tension and the compression. You know that? Because for here, okay, this is Shanghai centers. I like this part. We'll arrange a lot of tension and compression bars. Because you can see this bar cannot bear in the moment, right? Just the function for this bar is compression tension, like here, like this one. Only compression tension. Moment in here connection is 0, right? And also for bending steel beams, for comparing the bending with some steel beams, and the tensional bending and the bending moment is also included steel column. So it's very simple for steel structure. You can see shell, cables, bars, beams, columns, support areas, almost is basic component, right? And the design procedures for here, it includes the code. We normally use the GB 50068. This is Chinese code for your design the steel structures. Like other building structure, steel structure follows the unified standard requirement and adapt the limited state design method based on the probability theory expressed by particle coefficient. Okay. And the following chapter, following should be learning method. We have some course about the steel structure, complex structure, strong theory. And we must take good notes, understand theory problems and the mechanics, strengths per class review and after class review. And keep practice, avoid having some. Okay. So next, now we begin the next chapter. So for this part, we're beginning to study the steel structural materials. The first part of this, it includes 6 parts. First thing to tell you the requirements for building steel structure and some performance tests. Performance test. For you, when using the materials, we should do some material tests to check the strength and the basic behaviors is meeting the basic requirements of the buildings. And also you can imagine according to the word performance test the main factor on the performance. How to understand this? According to the performance, we can control some basic functions and factors to change some behavior of the skills to make a different performance of the skills. And the yield condition under the complex stress conditions, that means in fourth part, that means we're beginning to the loading pace of the buildings, loading pace to check the yielding conditions of the steel. And also 5 parts we studied the advantage of the steel project and types that finally stop at the types of the selection of steel for building structure. This is basic for this part. The material part is not very. The materials should should meet the requirements for the buildings. We are normally building the steel structures. There are three main requirements. First is the high strength, practices and the practices and the good process abilities. Other requirement is can stop the temperature effect and also the corrosion, anti-corrosion, right? So why we need the high strength for buildings? This is the requirement. High strength. Which material is high strength? Other material. In steel is also different. We mix other elements of not element. Other material will be make the steel more strong. Concrete, and also other reinforcements. And you can find the concrete and the rock also the very high strength. But the buildings also need the plasticity and the softness. Plasticity, you can see plasticity. So concrete is not very big. It's not plasticity, right? So so this is why. So now have a rest.